So welcome back students for the discussion of some more questions. If S1, S2, S3 and Sm are the sum of n terms, sum of n terms of an AP whose first terms are 1, 2, 3 and so on up to m. Okay, means there are different APs. S1 is the sum of an AP whose first term is 1. S2 is the sum of n terms of an AP whose first term is 2. S3 is the sum of n terms of an AP whose first term is 3 and so on up to Sm is the sum of n terms of an AP whose first term is m. That's why respectively is also added in the question. If S1, S2, S3 and Sm are the sum of n terms of an AP of m APs actually, not an AP, it is m APs. Number of APs is m. There are m such APs, m APs. First has the sum S1 for n terms. Means S1 equals to what? If we separate them, sum of n terms of AP with first term equals to 1. Okay. And S2 equals to sum of n terms of AP with first term. This we have to write in our mind while reading a question. This time we are reading this question. If S1, S2, S3 up to Sm are the sum of n terms of m APs whose first term are 1, means first sum of n terms of first AP is S1. S3 is the sum of n terms again of AP with first term A equals to 3. And similarly, Sm is the sum of n terms of AP with first term A equals to m. Then we read the question further from starting. If S1, S2, S3 up to Sm are the sum of n terms of AP whose first terms are 1, 2, 3 and so on up to m respectively, and the common differences are 1, 3, 5 and so on up to 2m minus 1. Okay, means common difference of first AP is 1. It is given that S1 is the sum of n terms of one AP, first AP, whose first term is 1 and a common difference is also 1. S2 is sum of n terms of second AP whose first term is 2 and common difference is 3. S3 is sum of n terms of an AP whose first term is 3 and common difference is 5, and so on. Sm is the sum of n terms of an AP whose first term is m, we already have written, and a common difference is equal to 2m minus 1. It implies S1 equals to sum of n terms, we know the formula, n by 2 into 2a, value of a is 1, plus n minus 1 into common difference is also 1, equals to n by 2 into 2 plus n minus 1 is n plus 1. S2 is also, we know that sum of n terms of an AP has the formula n by 2 into 2a plus n minus 1 into 2. Okay. So what we have to prove? We will discuss that also. But first, what is the conclusion? After reading the question completely, first we conclude these things. S2 equals to n by 2, 2a. Value of a is 2 plus n minus 1 into common difference is 3. So if you open the bracket, 4 plus 3n minus 3, n minus 1 into 3 is 3n minus 3. So n by 2 remain outside the bracket, and 4 plus this 3n minus 3 becomes 3n plus 1. Okay. When we take d equals to 5, 3 equals to n by 2 into 2a. 2a. This time value of a is 3 plus n minus 1 into d is 5. This was 2, na? That's why I have made a correction in this. 6 plus 5n minus 5 is 5n plus 1. And Sm is the sum of n terms of an AP whose first term is m. So 2m plus common difference is 2m minus 1. So further simplify this also. Now first we will read the question further. These are the conclusion which we have obtained till now. This must be written inside the mind, though I have written on the board. While reading the question, we must write all this information in this manner. If S1, S2, S3 and Sm are the sum of n terms of MAPs, so there are MAPs. First AP has sum S1, second AP has sum S2, third AP has sum S3, and Sm means the sum of m terms of AP whose first term are respectively 1, 2, 3 up to m, and the common differences are respectively 1, 3, 5 and so on up to 2m minus 1. Okay, so we have used the formula for sum of n terms of an AP, n by 2 into 2a plus n minus 1 into d. Now we have to prove that, show that S1 plus S2 plus S3 and so on up to Sm equals to Mn by 2 into Mn plus 1. So now we will add them. The results which we have obtained must be used to prove equals to, now add this n by 2. In place of s1 we write n by 2 into n plus 1. In place of s2 we write n by 2 into 3n plus 1 plus n by 2 into 5n plus 1, and so on up to m terms. Why m terms? As there are m APs. So there will be m terms. Now in all these m terms, n by 2 is common. So if we take it common, first gives n plus 1, second 3n plus 1, third 5n plus 1, and last up to m terms. Now check whether these are also the APs or not, which are inside the bracket. With first term as n plus 1 and common difference a2 minus a1. If we find 3n plus 1 minus n minus 1, when one cancelled out 3n minus n, 2n again. a3 minus a2, 5n plus 1 minus 3n minus 1. So 1 cancelled out, 5n minus 3n, 2n again. Common difference is 2n, and this is up to m terms. So sum of m terms is m by 2 into 2a plus n minus 1 into d. Okay, so it is again then n into m, or 2 into 2 is 4. So mn by 4, and inside the bracket 2n plus 2 plus, open the bracket, 2mn minus 2n. This 2 and 2n will be cancelled out, and we get the right hand side, mn by 4 into 2mn plus 2. Now further, if we take 2 common, 2 will be cancelled out, 2 2s are 4 in the denominator into mn plus 1 when we take 1 common from this. Hope you must have understood this. So practice them with the method I have discussed and ask your doubts in comment box. If you have any doubt, you can ask it in comment box.